I would like to introduce our morning speaker. Aurelia is a developer, curious cartographer. She previously was building communities around code with CreditDB and has recently moved to the Mozilla Foundation. She's worked for nonprofits such as shahidi, Internews Kenya, and works in the open tech and nonprofit journalism space. She works for Girl Develop It, which is a magnificent organization, and it exists to provide affordable and judgment-free opportunities for women interested in learning web development. She's originally from Kenosha, Wisconsin, and holds a degree from UW-Madison. It is with great pleasure that I would like to introduce Aurelia Moser.
Let me get my slides set up. Okay, are they live? I'm too short, unfortunately, to see the little screen, so I just kind of have to hope that they're going. Okay, cool. Yeah, my name is Aurelia Moser, and the title of my talk is Storytelling from Space, Satellite, Citizen Science, and Stylish Slippy Maps. When I moved to Mozilla, I actually worked for the Mozilla Science Lab that still does quite a bit of GIS and mapping. So I'm still in the same family of GIS work, but mostly work in web maps. And the image that you see in the background, I'm going to talk about quite a bit, not just this image, but also several like it. It's actually a satellite image taken with a Landsat 8 camera. So who knows Landsat? Who's familiar with the Landsat image database? All right, great. Yeah, so I worked a lot with satellite imagery at CreditDB, actually. And I like this image because if you didn't have text on top of it, you'd see kind of how painterly it is, right? It looks, it doesn't look like an image of the Earth. And that's because the land mass and the water mass were both masked separately and then recolorized and then reconstituted together so that you could highlight like nutrient deposits and sediment deposits and also vegetation. But this is the kind of stuff that the Landsat scientists, do. They post-process images of the world. And I like to start with satellite imagery because I think it's a really good model for web maps in many ways, or just photography in general. I think when you're building things for the web or visualizations or maps, you're often competing with one of the most advanced compression algorithms known to man, and that's in your eyes, right? Your eyes are capable of processing your 3D world, prioritizing it, understanding depth, perceiving colors depending on the quality of your vision, and all of that happens pretty instantaneously. Again, depending on the quality of your vision. But we don't really think about it. We don't have to think about it. And with the web or with any kind of web map that you might make, there's always a delay, right? You load, there's a little scrolly wheel, a delay in the screen. Even the half-second delay is a delay in your appreciation of the information. And photographs, by contrast, or even tiles for maps, load such a density of information almost instantly, right? You can see a lot in this photo. It's been post-processed. But you can see a lot even in the static image. It's not dynamic like web maps. It's not a Slippy map. And I think that's what we strive for when we make Slippy maps and Slippy map software. So that's what I'm going to talk about. So I'm going to show a few examples of Landsat images and the kind of things you can glean from them. This is an image of the sort of burn scar from a tornado in Wisconsin, actually, near the Wolf River area. You can kind of see how it slices across the center. So Landsat's great for detecting, even in non-colorized images, for detecting natural phenomenon. And it's also good for detecting urban phenomenon. So who's familiar with urban heat islands? It's sort of a collection of heat that develops around an area where there's heavy population of humanity. So these are just two cities, Buffalo, New York, and Providence, Rhode Island. And they've, of course, been colorized, from space. The world doesn't necessarily look purple, but they're beautiful, right? And they show something about humanity and not just about the natural environment. And then you also have these other things where there's a kind of fusion between the human and the natural. This is actually a continuous image. So it looks, I'm not sure what the quality of the color is, but the more orange section is developed areas where humans populate. And then the green area is more vegetation. But there's kind of a stark line in the center that you can sort of see between Guatemala and Mexico. And that's because in the 80s, Guatemala had a civil war and didn't have a lot of urbanization and development. So they actually let their forests grow. So there's a political border that's now reinforced by the natural environment. And you can see that from space. You can see that with satellite imagery. So, so to make these kind of arty images, and this is the canvas I normally work on, right? This is OpenStreetMap, and it's just an animated GIF of navigating an OpenStreetMap. But I like it because it illustrates, some of the problems with data visualization with maps, right? Because when you make a bar chart or a line graph, you're not expecting people to zoom infinitely, both in the Zoom user interface and then also right and left. And you can do that with the map canvas. So there's a lot of things that need to be corrected and adjusted so that people and the integrity of the data that's applied to a base map can be appreciated at all those levels. And then I also like to point out too, because I talk a lot about vector and satellite imagery, sorry. That when you scroll really fast on a slippy map, you kind of have the Borgesian map of the world, the size of the world in the palm of your hand. But there's still tiles that load, right? You still get this gray area over here that you see where before the tiles load. So the world is still building itself as you're scrolling. So you don't have infinite power. And so kind of mediating those issues is what we worked on a lot at CartoDB and what I worked on in mapping in general. And then this is a project that I kind of use for inspiration for the talk because I have a few friends who worked on it. It's called Losing Ground. It was developed by ProPublica, which is a nonprofit investigative news agency in New York. And they do a lot of longitudinal studies. And they do some map work too. So they use satellite imagery for this to understand a little bit more about Louisiana land loss across history. And if you scrubbed across the timeline at the top, the land mass would change and all of the photos would load so that you could see how the water was creeping in and how there are actual geo-named places that no longer exist because of the land loss in Louisiana. And when I saw a talk by the developer who made this, his name is Jeff Larson, he's actually a friend, but this was one of his slides. It's kind of a boring slide, but it says, but Slippy maps are optimized for location and wayfinding and not for awe. And that's really sad for someone who makes Slippy maps all the time, right? To have someone tell you that your work is not awesome, that it's just for navigation, it's just this functional thing. This is what I do all the time. I make a lot of maps. I make also charts and graphs and things. But I like to believe that there's some kind of beauty and artistry in map making too. So this is an example of a map, a beautiful map made with CartoDB. It's an ISO map, so you can kind of see the little striations and lines that indicate, elevation in Iceland. And you wouldn't necessarily use this for navigation, right? You wouldn't use it to take a hike across Iceland. But it's beautiful, the colors that were chosen and the way that it's represented. It's artistic and interesting. This is another map made with a library called Torque, which is our time series data library. It allows you to animate information that has timestamps in it on a map. So this shows people tweeting about the different candidates in the Indian election. So you can make kind of categorical maps too with Torque, and you can assign different hashtags with colors. So you can see pockets of places where people are talking about certain topics. And it's pretty. And then this is another one that was an experiment a journalist did to show people tweeting about sunrise. And you can kind of see he put a little sine wave across it suggesting when the sun is going up and down. And this is just an animated GIF, so it's going to jerk back and forth. But you can sort of see how it hugs the line, at least in the US. And then, of course, there's always random people tweeting about sunrise that aren't actually experiencing it at the moment. But those outliers, you still include it in the data, because you want to have your data to have integrity. But it's a beautiful map, and it actually got a lot of attention for Torque. So we promoted a lot. And then, so coming back to the satellite imagery stuff, our inspiration, and most of my inspiration for a lot of my work comes from NASA, mostly for their analyses of their photos and the photos that they provide that are open and freely available, and then the beauty of the imagery, both altered and not. And this is another sort of stitched together view of a Landsat captures across what would be a normal base map, so you can see how it matches up with the photos. And when I talk about Torque and I talk about satellite imagery, I talk a lot about Spacetime because I think it's a very interesting model. It's more of a mathematical and a physics concept, right? But some of the keywords for it are the same as the keywords that you'd use for web development or for developing maps. So events and coordinate systems, like the events that you trigger when you hit a button on the web. You're dealing with that with a model that incorporates both spatial representations but also time as an element in that. And I like this background image because It's collected from data, or it was displayed on the Landsat database, but it's about CO2 emissions in the oceans. And I like it because often when we're looking at maps, right, the oceans just sort of are blue or gray or boring. There's nothing really exciting about them. And what we focus on is where we live. So as humans, we focus on the Earth. But this sort of inverts that paradigm, and the thing you see first is the oceans and not the Earth. And that's a lot of what we worked on at CreditDB. So inverting paradigms in maps. This is another example of cool things you can see with Landsat and with satellite imagery that you wouldn't have scope on because you can't see from space as a normal human. So seaweed aquaculture, who is familiar with how seaweed grows and is harvested? Not many folks, right? Not many, not myself, certainly. But if you zoom at a certain level, you see these really interesting and sort of weird patterns that almost look like little settlements, right? It's like farmland, and that's how it grows. But that's something you can see with Landsat imagery. That's what you can see with this dense, high-resolution imagery from space. So it's actually really useful for understanding how humans and wildlife in general grow and live. And then a while ago, I was kind of obsessed with shrinking lakes, so I did a bunch of projects with shrinking lakes all over the world. Like Mexico City used to be a lake, right, and now it's a city. So I did a lot of stuff with historical lake data, which is available actually through Natural Earth if you're interested. But there's a lot of side-by-side comparisons of lakes in Landsat as well. And this is Epican in Argentina. There was a flood. Or an overflowing of a few of the lakes at one point, and then they started to shrink progressively. So even in these static images, right, if you stitch them together, you get a sense of time series, you get a sense of space-time. So that's what I worked on a lot. And this last image that I'll show sort of shows the recession of the Columbia Glacier. And they actually have many more captures that they stitch together that allow you to see a real time series of this information. But it was quite popular and got picked up by Nature and promoted Landsat a lot too. So. And it's beautiful, right? It's another beautiful image. And this quote by Todd Schroeder I also like to highlight because it talks about the entire Landsat Archive being freely available, so anyone can search it, which is really miraculous. They also have an API now called AONNet, which is really awesome, and you can get a lot of real-time or sort of real-time weather information almost from satellite imagery from it. But I like to talk about that because our software for CreditDB and for shahidi and for all the companies that I worked for has been open source. And I think that's super important to the ethos of how we develop this kind of web mapping. So this is Open Whatever Map. It's a collection of different base maps that are stitched together kind of like a patchwork quilt of all the possible base maps. But when you include satellite imagery in this, you expand so much beyond what's available by the free defaults or what you can put in Leaflet. It's still a cool representation, though, of all of the breadth of base maps available to just average citizens who want to make maps for the web. And one of my favorites, actually, or all of my favorite base maps are usually the ones that are the least useful. So, like the watercolor base map by Stamen, I love that one, and it's not at all useful. To wrap up the kind of intro, going back to the Jeff Larson quote about maps not being awesome for the web, this is actually XKCD, and I just changed the second tile to be I love cartography instead of cryptography. But I feel like he could easily be dealing with, legacy GIS software machines in that little slide. So that's kind of what we worked on a lot, was making awesome maps and not awful maps, but things that inspired awe. So how did we build this stuff, and what kind of software did I get to work on? And why is it even important that average citizens can build maps, right? Because we have people who are very experienced and accomplished in this, so why would we want that? This was a project developed in a fellowship program I was in at a hackathon I was at called Disputed Territories. Some people may have seen it, but it involved the students that worked on it threw their IP addresses on their computers to different locations and then took screenshots of Google Maps images of those places to see what it looked like from different locations. So you get situations where in Bhutan, you have a whole other lobe of Bhutan that's at the top. And then if you're in China, China owns that lobe of Bhutan. But if you're in the US, then Bhutan is full and flush and has the lobe again. And we don't think of maps as being so political anymore because we feel like they're so available to us, right? Everybody has a mobile device. Everybody can search for a location, and you assume that navigation and location information has integrity, right? But we have constant instances of the maps that are being provided to us as not being necessarily accurate or satisfying some political need or desire of the location that we're in. And Google makes those contracts too with different companies so that they can have their maps available in those locations. So it's important, I think, that citizens use OpenStreetMap and can make their own maps so that people on the ground can actually make maps of their areas and don't feel oppressed by map titans. So this is a map that I made very quickly actually with OpenOSM data, so OpenStreetMap data, and the Humanitarian OpenStreetMap organization, which has maybe the best acronym, HOT. They work on remapping in locations that have natural disasters or even just general human disasters that cause disruptions in transportation networks and change in how the map looks. So this was a map that I made very quickly after the Nepal earthquake to show OpenStreetMap people coming in and editing the roadways. And then I categorized it by all the different types of tags associated with roads. So you can kind of see it uses torque. There's like little blips and bubbles of activity, and those are people moving roads and editing them and changing it online. But all of this data was available and free. It uses a humanitarian base map that Damon developed, actually. And I built it in less than 20 minutes with open data from OSM. And this is what I used to do it. It was very short. I used CreditDB.js, which is a JavaScript library I'll talk about shortly. But it involves a little tiny SQL query that orders all of the sort of blips that you saw in Torque by the ID number or of their entry, so the timestamp of when people were entering them, because they didn't publish the timestamps, but they did take them by the order of people, making changes. So I did that, and then I had some simple CSS to sort of, make it a categorical map and control the torque blips and how big they were. But all of these are open, and all of this is available. And if you view source on the website that I made for it, you'd be able to see all the code and how I made it. And that's the kind of stuff that we worked on at Cartobeat Debut, was enabling that kind of thing. CrowdCSS too, I don't know how many people, I'm sure a lot of people here are familiar with it, but it's a sort of a takeover from CascadeNick, which I'll talk about in a little bit. Developed by Mapbox and documented by Mapbox, and actually available in CartoDB too. So it's a CSS flavored language that allows you to style maps and by styling data sets. So instead of styling a selector like you would in regular CSS, you're styling on data. So you can say, at this zoom, you can even write cool conditionals like at this zoom level, change the color or something. It's really nice. So this is the kind of stuff that I work on, and I showed this because this is GitHub. And I'm going to talk briefly about the organizations that I worked for and the kind of open software tools that they developed for cartographers. So I worked at Ushahidi, which was mentioned before, but this is their logo here. And then CartoDB is this tiny logo here that I'll show again shortly. And then the Mozilla Science Lab also, I worked at a lot of open source organizations, so there's a lot of logos there. But let's start with Ushahidi. So Ushahidi is a word that means witness in Swahili. I don't know how many people are familiar with it, but it's a project that grew out of Kenya, the 2007-2008 Kenyan elections. There were a lot of riots because it was a sort of military coup, and the media wasn't reporting on it. So a few citizens got together and they made a deployable mapping platform that would allow you to set up a map on the web, and then people could text in with feature phones and also smartphones their location and say, this is happening in my neighborhood, violence is happening in my neighborhood and no one's reporting on it. And then it would be public on the map, but they would be anonymous. So they'd be somewhat protected. But people who were reporting on it or aid workers who needed to help people out could go to those locations and help. And so the challenge was a lot of natural disaster areas, or not just military coups and internal disaster areas, but also in Haiti in 2008 or 2010, OpenStreetMap actually teamed up with Ushahidi to build a deployable Ushahidi map that humanitarian workers could use to identify places where people needed resources when all the road networks were destroyed and get them the resources that they need. And those are the kind of challenges that we were solving, kind of crowdsourcing citizen opinion and also problems in societies. And our code was all open source, still is. It's all available. And it's undergone quite a bit of retooling. It originally was a sort of PHP deployable map that was non-trivial for someone who wasn't a developer to set up, even though it was open source. But now it's a lot of Node and a lot of more modern web languages, so it's much more approachable, accessible. And not everything was a crisis, right? People also built bike share maps with Ushahidi. They built a lot of citizen reporting apps with Ushahidi. So this is the one you're seeing on the left. It was a bike share example of an Ushahidi deployment. And then out of that, Ushahidi ended up developing a lot of hardware tools to support mapping. So this little sort of stack of phones over here that you see, that's a kind of tiny little device, was called Brick. And it grew out of our frustration with working in Nairobi and never having good internet. So it's very hard to develop software when your internet goes down and the government won't repair the transformer that blew for 3 weeks. So this was a tool that one of our hardware developers who builds custom circuits for medical equipment created that allows you to pop in a satellite phone chip, so a GSM satellite network chip, into the side of this device and then amplifies the signal to support up to 20 devices who connect to that local network. So you have a local internet that's about the size of 3 cell phones stacked, and it has serial ports for collecting data, sensor data. So if you're taking it in the field to a place where you want to collect sensor information or environmental sensor data, you can do that and upload it to like a Dropbox or something if you want, because you'll have a local internet with you. And then the product was something like this. When I was working there, we were trying to revamp the view of Ushahidi. So the original bike map was written with the original Ushahidi, but this was a more friendly one, and we were trying to make it a little bit more like a Google product, right? Because we realized kind of that the worst thing you can do to people in crisis is give them ugly software and say, now figure out how to deal with your crisis via this horrible software. And so we were trying to make it a little bit more user-friendly, and that was a lot of the ethos and plan for Ushahidi when I worked there. And then CreditDB, which this is the little logo. It's a little elephant kind of on a map pin, although I originally thought it was sort of a hot air balloon at one point. It's kind of, or a torch. No, it's a bit difficult to see sometimes. But CreditDB, I don't know who's familiar with CreditDB in the room. Great, awesome, cool. So the problem or the challenge that we were solving for with CreditDB was something that I actually had legacy from Ushahidi. So Ushahidi makes its money, because it's open source, by having people contract them to make maps. And people, because we were making all these crisis maps and getting all this press, people kept coming to us with their data and saying like, okay, map it. Can you just map it? Like, this is, NGO data. So you work in crisis situations. You must know how to deal with these data. But we built an engine for collecting or crowdsourcing information from citizens from phones. We didn't build something to drag and drop data onto a map. But we had these contract projects and we had to fulfill them. So I ended up using Geo to work on this project with Info Amazonia, which is a group out of Brazil. They developed Geo as an open source WordPress sort of platform that allows you to integrate maps with WordPress blogs. And this map, LandQuest, was a journalist's idea in Kenya, actually, to allow reporters to report about extractive industry in Kenya and Tanzania, which is when a company comes in, sets up shop, drills for oil, but exports all the money and the profits and doesn't hire anyone who's local, which means they're just raking the resources out of this country, but not actually feeding the economy of the local community. So this was a combined map that showed different drilling stations and had little anecdotes in the tooltips, and then it also had a bunch of narrative stories with open data attached to them that the journalists were writing. But this was something that Ushahidi couldn't solve, so I had to go to a third party. And that's something that CreditDB kind of deals with. So CreditDB also is open source, right? And it's kind of two different things. It's both an editor view in the browser, where you can log in and you can view your tables and everything and view your maps. And then it's also a series of libraries and APIs that allow you to, as a developer, build your own maps for the web. So here are a few examples. The one on the left used to be very dynamic, actually, but it's just an image. But it was another Twitter map of people tweeting about Ebola. So you could see kind of pockets of when there was a scare in Texas, and all of a sudden all the Texans were tweeting about Ebola, and like, who's going to get Ebola? So those kind of conversation pieces are very popular to do with Torque and with CreditDB. And then we have a bunch of people who build little startups out of it. So the center one is actually a kind of choropleth map made from a lot of different open data sets in London. So a group that wanted to do real estate selling built a kind of complex map with census data and crime rate data and all these other data sets that complement your decisions about where you want to live. And then they would show this to their clients and say, like, these are the most dangerous areas, or this is the cheapest area, but it's also the most dangerous area. So we had a lot of projects like that because it was open source. You could build it into your projects, and we couldn't say, no, don't do that. And then the last one is actually a bunch of students at Yale at the forestry school who built a map that allowed you to give different countries scores based on their how pro-eco their governments were, so how much they supported nonprofits and NGOs who were working in supporting sustainable living. And you could actually go in and change things and say, actually, there's an NGO down my block who really works hard for this, and the government gives them funding or something. And so it became a participatory sort of map of different ecological programs globally. And so the product of CreditDB is kind of like this. If you're using the browser version, at least, it's a bit hard to see, but I'll show a demo shortly. So when you have your data, you just kind of drag and drop it into our interface, and it's basically a Postgres database in the cloud. So it allows you to create tables with your data sets. It will automatically geocode them, and then you also have a toggle view where you can see the map version and build maps like this. And then there's a little tray that allows you to run SQL queries, so you can do querying and filtering. But you can also, we have a thing called filters that's like SQLite that allows you to kind of kludge together a SQL statement based on like a search, almost like an Excel table. You can search and filter. Or you can set date ceilings if you're using time series data, for example. And then there's also a Carto CSS tray, but there's also a little wizard that allows you to click buttons. So if you're not comfortable with CSS, you can just click the buttons and it will generate the CSS for you. So that's what the product looks like. And this is sort of the architecture for anyone who might be interested. Some of these things might be familiar to people, like Mapnik, which is the tile server, right, for OSM. Leaflet, Gmaps, and OpenLayers are all options for the base layers for CartoDB. So if you're building as a developer, this is the kind of stack you're working with. And it looks very similar to the right side, which is actually the editor interface, which is based mostly on APIs, and that's what you log into when you log into the browser version. But three things that I want to kind of highlight, or four things, I should say, are the top, right below the browser, there's the CartoDB.js, which is a library that allows you to build maps with CartoDB. It's also built into the editor interface. And Odyssey.js, which is a kind of chapterized storytelling extension to CartoDB that allows you in a YAML markdown file to kind of make slides with your map. So if you have, for example, for the lakes project, I had 6 lakes, but when you zoom all the way out to the globe, you can barely see the lakes. So I had to create some way to zoom to kind of curate the story that people were going to read in the map. So it allows you to specify zoom level and also center lat long for each of the slides. So it's kind of like a PowerPoint, but for, for a map. We have different views, though. You can do like a scroll 1, 2, where the map updates as you scroll down the page that you're building with information to support the map. But yeah, it's a kind of a cool project and also open source. And then Torque.js is the library that I said for time series data that I'll talk about a little bit more technically in a second. And Vecnik.js is, sounds like Mapnik, but it's more dealing with vector tiles instead of raster tiles. So that's another library that we have. It's also open source. So this is kind of what the editor interface looks like if I have a data set. We accept most of the common formats, KMZ, KML, shapefiles, CSVs, Excel files even. You load it in, and then it will tell you in this little scrolly window how long it's taking to connect into your tables. I don't name my tables particularly well, but sometimes, sometimes the metadata is good. So yeah, so then it loads, and you get your data hopefully geocoded. It reads through all of your data and tries to find the location information. So if you have zip codes, if you have street addresses, if you have latitudes and longitudes, even better. But if you don't, it also has a bunch of preloaded lookup tables for administrative districts too. So it will recognize names and places and points, lines, and polygons. So this makes the points, and then you have your little SQL tray or whatever you pull up on the side. It's also supported, I don't know if everyone saw in the architectural diagram, but PostGIS is built into CartoDB. So if you want to write PostGIS functions in the SQL tray, you can do that. You can also write them in code with the SQL API. So here in the wizard, you can edit the colors, or if you're doing a chloropleth, you can select your binning algorithm. You can do a lot of other fancy things. And then there's also tooltips that pull into your sort of hover functions on top of the points, lines, and polygons, any data from your data set using mustache notation. So if you're familiar with that, all you have to do is call the column name, like in this case, description, between mustaches. And that will pull in the data every time you hover over something, you'll get an update. That's different. So down at the Mozilla Science Lab, so what do? We also do a lot of GIS stuff, but we mostly support the hard and soft sciences and any scientists or postdoctoral researchers who want to build open source or open research practice in their communities. So this is a map example. That we run a fellowship program. Right now it's supporting 4 fellows. One of them is at the University of British Columbia, and he's working on this project called Urban CO2 that's using his advisor's data on CO2 emissions and throughout Vancouver, and he's plotting them on maps. And because the advisor has been collecting data for many years, never visualized it in any way, so we're sponsoring him to kind of support visualization building for the research institution that he's based in. And it also allows you to kind of pick up a little sensor kit and deploy it in your neighborhood and then edit the map if you want to. So it's a very cool interactive community project. And then all of our code is also open source. We build a lot of code that sort of enables scientists to build open source things. Doesn't necessarily, it's not always geared toward maps, and it's not always geared toward sciences, but it's still in the same vein of building a platform for people to build on top of and build their own creative work. So we have things like study groups, which are just forkable websites, basically, that allow you to create a study group in your community around usually Python and R, because those are the more statistical and scientific programming languages. But we have a whole library of open source lessons that you can just set up and teach in your own communities, and that's all free and open source. The fellowship program, these are our fellows. They're all very great. They're mostly developers and programmers who work in the sciences. So Joey was the one who built the Urban CO2 project that I just showed. Chrissy's an insect ecologist. Richard is a computational biologist. And Jason is a biologist, but he's also working on a project called the Resilience Project that allows you to identify people who are naturally resilient to different diseases and then help scientists research why they're resilient to AIDS and how we can develop cures based on that. And then we have a project called Collaborate, which allows you to port your GitHub project into a scientific community space and allows scientists to join in on open source projects in the sciences. Some of them are map-based projects, like this one. Some of them are also just general science visualization projects. And this is like our little website where you can find all those things. It's mozillascience.org. So map science, so how does the scientific method work for maps? That's what I'm going to talk about a little bit. Actually, my title at CreditDB was Map Scientist. There were only 3 of us, and we were just basically R&D for for CreditDB, but it was always such an obscure title to give people like, I'm a map scientist. And you're like, what is that exactly? What does it mean? I'm not sure I've ever had a real title at a job for the past several years, actually. So, but this is a project that CreditDB was used for and actually worked on to support. It's called Global Forest Watch. It actually uses everything in the map kit you can imagine. It uses Google base maps, it uses CreditDB, there's some Mapbox stuff in there, but they also have satellite imagery as base maps and Landsat imagery as base maps, and the project was geared toward providing links to open data around conservation and forestry and forest availability and forest fires in different locations. So they have so many data sets. They have a whole library of data sets that are open to anyone, and then you could apply them as layers, as raster layers on top of other base maps to see kind of what the general look was for the world. This was the other project I showed you before, the Illustrates project, which was the one in London where they made a chloropleth of different locations where you should live and where you might want to live. And I like to show it because they also partnered it with charts and graphs. One of the values of having open libraries and APIs is that you can combine them with any other libraries. So if you have a charting library and you want the tooltip to update according in that chart or graph according to where you hover, you can make that happen with CreditDB.js. This was a project we were really proud of, actually, because the New York Times used CreditDB, but then they asked us to remove our logo, and so that was a bit of a bummer. But we still touted as being like, yeah, New York Times used us. So this was a project to investigate the curvature of the Amtrak corridor after that big derailment a while back. And they used CreditDB to kind of color the line according to the curve level radius. And this project I love to show because it's a student. His name is Michael Weaver. He is not a programmer. He is not a geographer or cartographer. He is a historian. and he's been collecting data for his thesis on how long it took people to travel to different locations in the US at different times in history. So he has this little toggle where you can select a button for 1880 versus 1900, the difference being, not a lot of automobiles in the early part. So when you click on a location, it recalculates the rainbow to show you how long it would take you to get to different locations. And I like to show it because the software was made really for people who don't know how to do most of the things that the software does. And I think that's great, that people can just approach it and make really cool maps. And then this was a chart that I made actually from map data. So one of the values of the Maps API and the SQL API in particular is that you can actually just use CreditDB as a data store and then query your data remotely and pull that into any visualization project you want. So it doesn't even have to be a map. It can be a chart. This is kind of bleak, but it's Georgian counties and the number of traffic fatalities in the year 2006. I don't know why I picked a rainbow for that. Probably not appropriate. And then we did a lot of experiments too. This is Chris Wong, who was on my team, built this project called Urban Scratch Off. So it allowed you to explore kind of historical aerial imagery and then scrub it off to see the underside of what it's like today. It was a really cool project and just sort of random and experimental, but a great way to appreciate historical maps and even like satellite imagery. So time series, so people always ask about torque and how it works. So I usually like to try to talk about it just a little bit. I think about it as space-time sort of in a box, and I'll describe why that's relevant in a second. But this is actually, this is a torque map. So one of the cool things about CreditDB is you can pick your own base maps, or you can even upload your own image as a base map. So that's what this guy did. He uploaded an image as his base map, and he animated a GIF with torque. So normally this guy kind of jumps over the little vault, but I took the animated GIF without very good internet, so he kind of always stops and he sort of hitches, and I sort of like it as a nice metaphor for how we started working on torque and time series data with maps, because it's so Sisyphusian, like he's just never going to make it. He's just never going to make it over the vault, and we're like, how are we going to do this? How are we going to make it work? So how does torque work? Torque uses data cubes, so instead of tiling data, it sort of cubes data. I think about it as the flux capacitor for maps. I don't know if that reference is going to go over. Flux capacitor, everyone knows what that is. I feel a bit timid about it because I taught a class at Parsons last year and none of my students got the joke. And it was even like the day that was, I forgot what day it was, but the one that appears on the little flux capacitor screen. None of them knew the reference, and I was like, oh no, oh no. So it's slices of data on the client, and I just have this cube as kind of a visual metaphor for how normally you're mapping spatial data things to places, but incorporating time creates a whole other dimension to what you're doing. So unpacking the Rubik's Cube of that, why would you want to do this, and what's great normally about torque rendering? Well, it's fast, it's light, and it caches quite well, but it's kind of lossy. You might think about, it actually depends on a type of compression that is used in PNGs, or PNG files. So, or when you think about JPEGs versus PNGs, anybody who does like data management or media management knows that some of those are more lossy than others, right? So dealing with that lossiness and also making maps that have integrity was really tough. And also, again, just to reintroduce this idea that when you're dealing with time series data on a map, you're also dealing with a ZUI interface. So you're dealing with the Zoom user experience of people expecting the map to be just as great at all Zoom levels, and they want all the data, even if it's populated dynamically, they want it to populate dynamically at all levels perfectly and not mess up and readjust dynamically as you're zooming. So it's a non-trivial effort. So it uses a thing that I mentioned before called delta encoding, which is what PNGs use, which is why I have this little image over here, and gzip compression. And it bins by step, which means that it bins the data. It takes account of the extremes in your timestamps, and then sort of creates bins based on the amount of data that you have and how agreeably they would fit into those timestamps, and then it repackages them so that they are efficiently rendered on the client. And the types of data that you'll see are very different, right? Some data is very regular, like Twitter data, very easy to render because it's all very regular, and they're always like, standardizing their metadata that you can export to the Twitter API. So it looks kind of like this when it's cubed, so straight lines. But sometimes, often you're dealing with data that's pretty messy. Like the first Torque project was transcribed logbook data from mariners or from boats, but it was historical data. So sometimes, captain's log, June 7th, and then also a time. And sometimes, June, no year, so you have all this jumping around. So it looks a bit more erratic, and controlling for those two types of regular and non-regular data sets was also a big concern. So, dealing with spacetime maps and dynamic maps and time series maps, I wanted to show some torque maps in particular. But first, I'd like to start out with an example of a map that isn't a torque map, but something that torque improves upon. So this is actually from the Internet Archive. It's a War Department weather map, and it actually has a date and a time. August 26, 7:35 a.m. So as soon as this map was made, it was dated. Like, probably before it was done, it was already dated. And this kind of static weather map maybe is something that we were thinking about a lot when we started working on torque. So this was the first torque project. It was called, it was a partnership with a project called Old Weather, which is out of Zooniverse. Zooniverse is actually a partner of the Mozilla Science Lab now too, but they develop citizen science programs and projects that allow any citizen to log in and help scientists tag images or help them, find weird patterns in DNA. So they give you instructions, and you can help identify, like one of their projects, Snapshot Serengeti, has all of these photos, thousands of photos of different Serengeti animals, because they have those little cameras that just take pictures every time they see movement. And so they have thousands of these, and that would take an intern or a postdoc, months to process. But they put it on Zooniverse and said, hey, if you see this horn pattern, identify this animal as this. And in 2 hours, 16,000 images were tagged appropriately. So that Old Weather was that project, but it was meant to transcribe the logbooks that also had weather reports in them. And from there, you could extrapolate like trajectory data. So this is the first sort of janky torque visualization showing those trajectories of those boats, so it's super fast. There's other projects too, like Info Amazonia, the group that developed Geo, which was the WordPress theme that I used for, or that we used on LandQuest. They also do a lot of, as their name suggests, info about the Amazon. So they wanted to do a forest fire map with torque, and so they styled it so that it looks sort of like burning or kindling. And this is one of my favorite projects. It was built at a hackathon in New York. It uses scientific data. So there was a scientist who had a bunch of data. For years, they've been attaching little sensors to porpoises and sea life and following them on their migration trajectories. And they just had it in tables and hadn't done anything, visual with it. So the student made a little interface where you could use torque to visualize those trajectories, and then also filter by type of animal and number of animals. And you can kind of see how they like cluster in certain pockets, like near the Antarctic or near the Arctic. But it's a really beautiful project and very interesting. And then this was a project that one of the last projects that I got to work on, or that we worked on at CreditDB, was this bird watching project. So these are charts. In Europe, they have bird watching committees in different countries, and they log their data about different species that they see and everything. And they had all of this data, and they wanted to make a map with it because they had these little charts showing the frequency of different species. So we made a sort of side-by-side comparison map that showed, that allowed you to choose the species of bird and then compare that to environmental data like temperature. So you can see as it heats up, the birds go up, and as it cools down, the birds move back down. And I like to show it too because you might notice that Spain has no bird watchers, and you're like, what's up with that? Europe, like the Spanish are just ornery and they don't want to help. But it turns out they are kind of ornery actually, because the reason that they didn't submit their data was because Catalonia had piloted the project, and they were like, well, the Catalonians are doing this, we're not going to submit our data. So yeah, that happened, and maps are still very political. But another thing that you might notice too is that the projection is slightly different than the average projection, and that's because in CreditDB you can change the projections with SQL. So they asked, the Catalonians requested that we pick a projection that amplified the size of their area. So it's slightly different. And then this was a project actually built by a journalist, again, someone not trained in cartography, but he took Yelp data and searched for tags, touristy versus not, and then made kind of a heat map of the touristy areas in Las Vegas. And you can also do all kinds of weird composite operations in CreditDB that are just drop-downs, sort of like Photoshop on top of your map. So you can do things like make it glow when a certain number of things overlap. So that's why it looks like that, and it doesn't look necessarily like the little key down here. And then this project, that I really love actually was a partnership with Chicago Sun-Times. They wanted to do research on snowplow trajectories in Chicago, showing like what neighborhoods got prioritized, and then also match that up with aldermen's like home locations to see if certain things were shady. But so we did that, and the journalist was super excited because he was like, "Oh, there's this patch over here. I bet there's a bunch of aldermen that live over there. I'm going to investigate this area." But then when we looked at the satellite imagery, it turns out that it's just a snowplow car park. Like it's where all the snowplows go to bed. And that's an important point too, because in developing all this open source software for non-trained people, you have people all the time who come to us and say, well, that map wasn't accurate, or the chloropleth binning algorithm that they used for that was not actually the right one, and you should have trained them to do that. But there's only so much liability that you can absorb if people refuse to investigate their own data, right? So at least he was inquisitive, and he wanted to actually find out what was there, and he didn't publish the results prematurely. We also did a lot of partnership projects, and we have a data library that is available to everyone to browse in CreditDB. But this was a project I worked on with the GTL Project, which is the global database of events, languages, and tones. It's a Google project, actually, that aggregates all formal media posts and then subclassifies them. So like a BBC article, it will subclassify it by a bunch of different tags and by languages, over 65 languages. And they provide an API that allows you to access all this information. So if you want to know what media outfits are covering a certain topic, you can search through the API. But the problem is that the API is this huge, sort of monolithic thing that's very unapproachable for a lot of people, and people also don't know what to do with it. They're like, well, that's great, and I'm glad that information's available, but I don't know what I'm going to do with it. So we partnered with them to make a bunch of maps to show why this might be interesting. So they have a little profile on CreditDB with like 30-some maps. And then we built this little tool called the GTL Geographic News Search with Kalev, who runs the GTL project solo, actually. And you could search for tags and see sort of a heat map of the last hour. And also, GTL has a subclassification for emotions, kind of, so they can read the text of an article and kind of identify roughly how angry or antagonistic it is, or how happy and positive it is. So you could also assess the emotion in those articles based on those different tags. And then people got very interested in it, and they wanted to do their own searches. So this was a project in partnership with a journalist at Foreign Policy magazine who wanted to do searches on animal poaching across the world. So when you start developing a quick map using the GTL sort of connector, you realize that there's a lot of edge cases for that because you're polling all normal media. So you get poaching for animals, but also poached eggs. You get poaching for a hire. You get a lot of other things that might, you end up running all of these edge cases, and by the time you're done, you're like, this machine learning thing, man, it doesn't really work. It's really tough. But the article got published and actually led to a follow-up article that showed how ISIS networks are getting funded by poaching and organizations that poach animals. So, what's the future of maps at CreditDB and at the Mozilla Science Lab, and what kind of things are we working on? I just wanted to go over a few of those. And I like to start with Mappa Mundi, mostly because it kind of goes back to the beginning, when I talked about Jeff Larson saying it was for navigation and wayfinding and not for awe. So Mappa Mundi, who's familiar with Mappa Mundi, map of the world? Yeah, so this is an example in the background, but if you looked at the Wikipedia definition, this is what it would say. Dynamic maps made to illustrate principles, a kind of teaching aid, never meant to be used as navigational charts, meant to preserve and illustrate classical learning easily. And so that's what a lot of our stuff, we have pretty beautiful maps and fancy maps and a lot of map effects that you can do. And it's not necessarily to help people get from point A to point B, it's to help people make beautiful maps with their data. And Mappa Mundi also are famous for having like sea monsters and creatures and stuff in the water. So it's not meant to be like, direct navigation. So how are we doing this? So we worked really hard actually on a data library in CreditDB because we discovered people were uploading the same data sets all the time. So census data or admin districts or subway lines. And so we have a huge data library now of a lot of clean data sets that you can just fork into your account. So you can just click on it and bring it into your account and layer it on top of your map data or below your map data. We also have projections. So this is one of my favorite features, is that you can write SQL queries for any ESPG projection. So yesterday we were talking about the Winkle triple projection, which is a favorite of Nat Geo, right? You can do that in CreditDB. We actually did it for a lot of our election maps, and because you can change the base map, you just make the base map a solid color, and then you change the projection of your data, which changes the shape. So you can do a lot of weird, interesting things. And we were working, too, on buttons that would allow people to just select from a drop-down the type of projection they wanted, because writing SQL is always like a scary thing. Nobody really wants to do it. So we're always trying to find ways to help people with that. More base maps. So this is my favorite base map, the watercolor base map, along with some time zone lines on top of it. Not very useful, but we have lots of base maps. And you can use Mapbox base maps. You can use all the types of base maps with CreditDB, actually. So that's pretty cool. And then this project I actually worked on with my coworker, Andy. It's called the Map Academy. And I think it's academy.cartodb.com. But it's basically Code Academy for GIS. So it teaches you about PostGIS functions, it teaches you about Postgres and why we use it, it teaches you about CartoDB.js and how to write JavaScript for maps, it teaches you about CartoCSS. So there are all these little lessons and interactives that you can play with to learn about these topics. So it's pretty cool, and I would recommend sharing it to students and such. This is an example of a map lesson that shows you about how to make a chloropleth, or a category map for election voting results or election voting dominance in certain districts. And we had to pick a fictitious place. Election maps are very common. A lot of journalists come to us and want to make election maps. So we wanted to make a tutorial to show them. And so we used a null island, which is the 00 location island that is often an Easter egg on lots of base maps. But this is null island, and it's a null island election map between the Nix and the Nada party. And so you could color the regions by the dominance of votes. So I guess it is chloropleth because it's number counting. But that's one of the exercises in the Map Academy. And then for Raster Map, you could always deal with raster data in CartoDB, but you couldn't view it until recently. But you would just load it in, it would be grayed out, so you could access that data set and add it to your map if you wanted to, but you couldn't just play with it and style it in the interface. So now there's a little interface for changing the CartoCSS and the SQL for raster maps, which is kind of nice. And then vector maps, we have this side-by-side kind of comparison of Mapnik and Vecnik rendering to show you why vector maps are awesome and why you might want to use them for some of the interactive effects that you expect from D3 and other libraries that are more advanced. And then one of the biggest projects that was released recently was called OneClick Maps. Internally, it was called Pecan Cookies, but it was a feature that grown out of the realization that most people who make maps with our software just make the default map. So our default color is hash F60. It's a hex value, and it's orange. And people inevitably always make orange maps. Like, we see orange maps and then we go, oh, it's a CartoDB map because it's just orange points on a map, or orange polygons. And no one ever plays with any of the colors or the changing. So we wanted to help people become more creative without forcing them to do it. So we built this little feature that when you load in a data set, it reads over every column in your data and assesses the most interesting columns. So it will look for columns that don't have null values, columns that have an interesting shape to the data set, or columns that have weird outliers that might be interesting to visualize. And then it will suggest to you in this little interface modal that you can click on maybe 8 maps that it discovers or 10 maps that it discovers that are interesting with your data set. And it will tell you the type of map, so if it's a category map on a country FP, which is the column name, or it's a chloropleth map on the amount of water content. This was a map for like water versus land use in the US. But it will allow you to select that, and then it will pre-populate all of the CartoCSS and the SQL that you need into your map, so you don't have to write any of it, but it already builds that map for you. So that's pretty cool, and it works pretty well. We used it internally for a while, and then it was released a few months ago. So we hope that makes people make really cool maps and interesting maps. And then also satellite imagery. So one of our sort of beta features that people have to request personally is the ability to use satellite-based maps, satellite imagery as base maps. So satellite imagery is actually quite expensive. If anybody who's dealt with it before, it's not cheap, and it's not necessarily accessible. Landsat, for example, provides you with satellite images, but at certain times you can't just say, I want, December 12th at 3 o'clock. They won't feed you that information. They'll feed you like the capture date that they allowed to be released on their public database. So the idea here was that you would be able to select a location and kind of draw a polygon around it, and then select a timestamp, and then request through CartoDB from Digital Globe a satellite image or base map for that. And you could request several slices if you wanted, so you could create your own time series. And this is kind of cool for people who are journalists who want to do like the Boston Marathon or something and find out where people were at a certain point, or they just want a tiny slice of the world, but they don't want to buy the default huge amount that's $3,000 or something. So that's something really cool. This is Burning Man, actually, for anyone who wanted to know. This is a satellite image of Burning Man, and we used it because it illustrates an interesting time in the history of this desert every year that otherwise it would be vacant and boring, but now it's got this weird semicircle that's pseudo-alien, and there are a bunch of people there. So we wanted to show time series. This is a project developed by one of our fellows at the Science Lab. It's called Arial Bold. You might be familiar with Arial as the font type. So what he did was he analyzed satellite imagery to identify letter shapes and then built a font out of those that people could use. And so what we're hoping to do is actually build it into Zooniverse and allow people to identify other alphabet letter shapes, so Cyrillic or something else, because right now it's only alphanumeric Roman. But yeah, it's a very cool project with satellite imagery, and it's playful, it's fun. And then we had a lot of fun side projects too related to maps. I have a whole pun Twitter devoted to ESS Pawns. These are some tweets from that. So we did a lot of weird, fun, but also awesome things, always making awesome maps. So here are the links if you're interested in looking those up. And thank you so much.